In this video, we'll review reference angles. To begin, a reference angle is a positive, acute angle that takes us from the terminal side of an angle to the nearest x-axis. Keep in mind the reference angle is always positive and acute. Acute means less than 90 degrees, or in radians less than pi over 2. And it always goes to the nearest x-axis, never the y-axis. We're going to use the notation theta prime, that is the theta symbol, with a little apostrophe, for the reference angle. Now let's look at a couple examples. Given each angle, we're going to sketch the reference angle. Here's an angle in quadrant 2. If the angle's in quadrant 2, that is theta is the angle that revolves there, the reference angle theta prime is going to be the little piece that takes us to the nearest x-axis. So that would be the little piece below the angle that takes us to the nearest x-axis, this piece here in red. If the angle's in quadrant 3, we're more than 180 degrees or more than pi, so it's going to be the little piece that takes us from pi to the terminal side, right here. Now if we're in quadrant 4, it's going to be the piece that takes us to the nearest x-axis. We're a little bit short of 2 pi or short of 360, so it's going to be the piece that takes us from the terminal side to the x-axis again, to the 360 or the 2 pi mark, here. Now, in degrees, the way we can find the reference angle, actually we want to find, if we knew how big theta was and we wanted to find theta prime, we could say that if you're in quadrant 1, because it's already acute in quadrant 1, theta is theta prime. Now, if you're in quadrant 2, you're more than 90 degrees, but not quite to 180. So you're short of 180. And the amount that you're short is going to be that reference angle. So here in quadrant 2, theta is 180 minus theta prime. Again, you're short of 180. In quadrant 3, you're now more than 180. And the amount that you're going to be more than 180 is your reference angle. So in quadrant 3, theta is 180 degrees plus theta prime. In quadrant 4, you're short of being that full circle, you're short of 360 degrees. The amount you're short, one more time, is that reference angle. So theta is 360 degrees minus theta prime. Now in radians, we're going to just change the degree measurements to radians. So instead of 180 degrees, halfway across the circle, that's pi. If it's 360 degrees, full circle, 360 degrees in radians is 2 pi. So in quadrant 1, your acute angle, you are less than pi over 2, so theta is theta prime. In quadrant 2, you're short of now pi, and the amount that you're going to be short is the theta prime, so theta is pi minus theta prime. In quadrant 3, you're more than pi, and the amount that you're more than is that theta prime, your reference angle, so theta is pi plus theta prime. And in quadrant 4, you're short of the full circle, you're short of 2 pi, so theta is 2 pi minus theta prime. And we'll use these to actually find the angles when we know what theta is, and we want to find the reference angle. So let's look at some examples. This time we're going to sketch the angle, we're going to label the reference angle, and we're actually going to do it in degrees to start. So if theta is 140 degrees, I want to find the reference angle. The reference angle is going to be the piece that takes me to the nearest x-axis. When I'm in quadrant 2, I know that the angle is theta, which is going to be 180 minus theta prime, which means that 140 degrees is 180 minus theta prime, which means that I'm short 40 degrees. So my reference angle, theta prime, is going to be 40 degrees. That is 40 plus the 140 was what makes 180. Now if I'm 218 degrees, I'm in quadrant 3. So here I'm more than 180. And how much more is my reference angle? So in quadrant 3, theta is 180 plus theta prime, which means that theta prime is 218 degrees minus 180. That means I am 38 degrees past 180, and that's my reference angle. Now if I'm in quadrant 4 now, theta is 330 degrees. I'm short of 360, and I need to figure out how much short of 360 I am. That's my reference angle. So 360 minus 330 is going to tell me that my reference angle is 30 degrees. I'm 30 degrees short of 360. Now let's try it in radians. We're going to sketch each reference angle and find this actual measurement. So if we start with theta being 5 pi over 6, I'm in quadrant 2, which means I'm short now in radians of pi. Now, in terms of sixes, because this is 5 pi over 6, 1 pi would be 6 pi over 6. 5 pi over 6 is 1 pi over 6 short of being 6/6. So my reference angle is 1 pi over 6. If I move to quadrant 3, here I'm 5 pi over 4. I'm more than pi, which in terms of fourths is going to be 4/4. So if I am at 5 pi over 4. That is 1 pi over 4 more than 4 pi over 4. So my reference angle is pi over 4. If I move to quadrant 4, for instance 11 pi over 6, I'm short of 2 pi. In terms of sixes, 2 pi would be 12 pi over 6. So here I'm at 11 pi over 6. 11 pi over 6 is 1 pi over 6 short of 12 pi over 6. So my reference angle is 1 pi over 6. Now I'm going to put up some more examples, and I want you to find the reference angles. So use whatever measurement system is given. So if we're in degrees, find it in degrees. If it's in radians, find it in radians. And I would recommend that you pause the video, try the 6 examples, and then resume the video when you're ready to check your answers. I'll give you a moment. All right, hopefully you've had a chance to work these out. Now the first example is in radians. We're in quadrant 2, we're at 5 pi over 7. We need to go to full pi, which is 7 pi over 7, to be the nearest x-axis. So 5 pi over 7 is 2 pi over 7 short of 7 pi over 7ths, 1 pi. So the reference angle is going to be 2 pi over 7. Now this next example is in degrees, and it's a negative angle. We're short of going to the 180 mark, and if we've gone 140 degrees in a negative direction, we're 40 degrees short of hitting that 180 mark. So theta prime is 40 degrees. Now notice I didn't say negative. The reference angle is always an acute positive angle, so we have to say it's positive 40 degrees. Now in the next example, we've gone negative 70 degrees. Again, it's in degrees, but negative 70, if I count just the actual measurement, 70 degrees, is already an acute angle. So to make it a reference angle, all we need to do is make it a positive measurement. So theta prime here, it's the same angle, but it's in a positive measurement of 70 degrees. Again, the definition of a reference angle is always positive and acute. Now the next one's negative 5 pi over 4. We've gone more than pi, so we're in quadrant 2, going in the negative direction, going clockwise, and we need to go back to the nearest x-axis. So that'll be this piece here. Now we've gone more than a full pi. We've gone more than 4/4. We've gone to 5/4. So we're pi over 4 more than pi over 4. So our reference angle is pi over 4. Now the next example is 16 pi over 3. It's going in the clockwise or positive direction of angle of rotation, but it's gone more than pi. It's in quadrant 3. So in terms of pi, in terms of 13ths, that would be 13 pi over 3, and we've gone 3 pi more than that, so we're 3 pi over 13 as the reference angle. Again, 13 pi over 13 plus 3 pi over 13 is what takes us to the 16 pi over 13, which is our angle of revolution. Now the next one, we've gone more than a full turn. We've gone more than 2 pi. We've gone 17 pi over 6. Now we're short of being that to the next mark. Now that would be 3 pi. Now 3 pi in terms of sixes would be 18 pi over 6. 17 pi over 6 is short of 18 pi over 6, and it's just a little short. We're 1 pi over 6 of being 3 pi, or 18 pi over 6. So our reference angle is pi over 6. All right, hopefully this helped you to understand how to do reference angles, and thank you for watching this video.